This is why you need to know about our solar system. Mercury is shrinking. Over time, the planet has been cooling and contracting, causing its surface to wrinkle and form cliffs known as scarps. These scarps can be hundreds of kilometers long and up to a mile high. This process has been ongoing for billions of years, and it's fascinating to think about how Mercury's landscape has changed over such a vast period. Venus spins backwards. Unlike most planets in our solar system, Venus has a retrograde rotation, meaning it spins in the opposite direction to its orbit around the Sun. This means that on Venus, the Sun rises in the west and sets in the east. The reason for this unusual rotation is still a mystery, but it's thought to be the result of a massive collision with another celestial body early in its history. Venus also has a very slow rotation, taking about 243 Earth days to complete one spin. Earth is 70% water. Our planet is often called the blue planet because of its abundant water. This water is essential for all known forms of life. The water cycle, which includes processes like evaporation, condensation and precipitation, plays a crucial role in regulating our climate and supporting ecosystems. Oceans cover about 71% of Earth's surface, and they are home to a vast array of marine life. The remaining 29% of Earth's surface is land, which includes continents and islands. Mars has the tallest volcano. Olympus Mons is a shield volcano on Mars, and it's the tallest planetary mountain in our solar system, standing at about 22 kilometers, 13.6 miles, high. It's nearly 3 times the height of Mount Everest. Olympus Mons is so large that its base is about the size of the state of Arizona. The volcano's gentle slopes are a result of the low gravity on Mars, which allows lava to flow more easily and spread out over a larger area. Jupiter's Great Red Spot is a storm. This massive storm has been raging for at least 400 years and is so large that it could fit 3 Earths within it. The Great Red Spot is an anticyclonic storm, meaning it rotates in the opposite direction of the planet's rotation. The storm's reddish color is thought to be caused by chemicals in Jupiter's atmosphere, but the exact composition is still unknown. The Great Red Spot is gradually shrinking, but it remains one of the most iconic features of our solar system. Saturn's rings are made of ice. These rings are composed of countless small particles, ranging in size from tiny grains to large boulders that are primarily made of water ice. The rings are incredibly thin, with a thickness of only about 10 meters, 33 feet in some places, but they span up to 282,000 kilometers, 175,000 miles in diameter. The origin of Saturn's rings is still debated, but they may have formed from the remnants of a moon that was shattered by Saturn's gravity. Uranus spins on its side. Unlike any other planet in our solar system, Uranus has an axial tilt of about 98 degrees, meaning it essentially rolls around the Sun on its side. This extreme tilt is likely the result of a collision with a large object early in the planet's history. As a result, Uranus experiences extreme seasonal variations, with each pole getting around 42 years of continuous sunlight, followed by 42 years of darkness. Neptune is supersonic windy. The winds on Neptune are the fastest in the solar system, reaching speeds of up to 2,100 kilometers per hour, 1,300 miles per hour. These supersonic winds are driven by the planet's internal heat, which is still not fully understood. Neptune's atmosphere is composed mainly of hydrogen, helium and methane, which gives the planet its striking blue color. The methane absorbs red light and reflects blue light, creating the vivid hue we see. Pluto has a heart-shaped glacier. This region, known as Tombor Regio, is a large, bright area on Pluto's surface that resembles a heart. It's made of nitrogen ice and is one of the most distinctive features on the dwarf planet. The heart-shaped glacier is thought to be relatively young, geologically speaking, and it may still be active, with nitrogen ice flowing and resurfacing the area. Pluto's surface is also covered in mountains, valleys and plains, making it a surprisingly diverse and dynamic world. The Sun's core is crazy hot. The temperature at the core of the Sun reaches about 15 million degrees Celsius, 27 million degrees Fahrenheit. This extreme heat is the result of nuclear fusion, where hydrogen atoms are fused together to form helium, releasing a tremendous amount of energy in the process. This energy radiates outward from the core and eventually reaches us as sunlight. The Sun's core is also incredibly dense, with a pressure about 250 billion times that of Earth's atmosphere. There's a planet made of diamonds. 55 Cancri e is an exoplanet that is thought to be rich in carbon, and under the right conditions, this carbon could form diamonds. This diamond planet is about twice the size of Earth and orbits its star very closely, completing a revolution in just 18 hours. The extreme temperatures and pressures on 55 Cancri e make it a fascinating subject of study. Additionally, some asteroids have moons. These small celestial bodies can have their own natural satellites, which are often captured by the asteroid's gravity. Our moon is moving away. The moon is gradually drifting away from Earth at a rate of about 3.8 centimeters, 1.5 inches per year. This is due to tidal interactions between the Earth and the moon, which transfer angular momentum from the Earth's rotation to the moon's orbit. Over millions of years, this process will continue to increase the distance between the two bodies. The moon's recession also affects the length of Earth's day, making it slightly longer over time. There are more stars than grains of sand. The Milky Way galaxy alone contains an estimated 100 to 400 billion stars, and there are billions of other galaxies in the observable universe. This means that the total number of stars in the universe is truly mind-boggling, far exceeding the number of grains of sand on all the beaches on Earth. Stars are born in vast clouds of gas and dust, known as nebulae, and they can live for millions to billions of years before eventually dying in spectacular events like supernova. Black holes warp time. These incredibly dense objects have such strong gravitational fields that they can bend light and distort time. According to Einstein's theory of general relativity, time slows down near a black hole, a phenomenon known as time dilation. The closer you get to the event horizon, the boundary beyond which nothing can escape the black hole's gravity, the more pronounced this effect becomes. Black holes are formed from the remnants of massive stars that have collapsed under their own gravity. Space is a vacuum. Unlike the atmosphere on Earth, space is almost completely empty, with very few particles and no air pressure. This vacuum environment presents unique challenges for astronauts and spacecraft, as there is no air to breathe and no medium to carry sound. The vacuum of space also means that temperatures can vary dramatically, from extremely hot in direct sunlight to extremely cold in the shadow of a planet or spacecraft. Comets are icy relics. These small celestial bodies are composed of ice, dust, and rocky material, and they originate from the outer regions of the solar system. When a comet approaches the sun, the heat causes its ice to vaporize, creating a glowing coma and a tail that can stretch for millions of kilometers. Comets are thought to be remnants from the early solar system, providing valuable clues about its formation and evolution. Some comets have highly elliptical orbits, taking them far beyond the orbit of Pluto before returning to the inner solar system. The Kuiper Belt is a debris field. This region of the solar system, located beyond the orbit of Neptune, is home to countless small icy bodies, including dwarf planets like Pluto and Eris. The Kuiper Belt is similar to the asteroid belt, but it is much larger and more massive. It is thought to be a remnant of the early solar system, containing material that never coalesced into a full-fledged planet. The objects in the Kuiper Belt are composed mainly of frozen volatiles, such as methane, ammonia, and water. Oort cloud is our solar bubble. This hypothetical cloud of icy bodies is believed to surround the solar system at a distance of up to 100,000 astronomical units, AU, from the Sun. The Oort cloud is thought to be the source of long-period comets, which have orbits that take them far beyond the Kuiper Belt. The existence of the Oort cloud has not been directly observed, but its presence is inferred from the behavior of these comets. The Oort cloud represents the outermost boundary of the Sun's gravitational influence. The Milky Way is a spiral galaxy. Our galaxy is a barred spiral, with a central bar-shaped structure composed of stars and a flat rotating disk that contains spiral arms. These arms are regions of active star formation, where new stars are born from clouds of gas and dust. The Milky Way is about 100,000 light-years in diameter and contains hundreds of billions of stars. Our solar system is located in one of the spiral arms, known as the Orion Arm, about 27,000 light-years from the galactic center. Exoplanets could have life. These planets orbit stars outside our solar system, and some of them are located in the habitable zone, where conditions might be right for liquid water to exist. The discovery of exoplanets has revolutionized our understanding of the universe, revealing a vast diversity of planetary systems. Some exoplanets are similar in size and composition to Earth, raising the possibility that they could harbor life. The search for extraterrestrial life is one of the most exciting areas of modern astronomy. Light years measure distance. A light year is the distance that light travels in 1 year, which is about 9.46 trillion kilometers, 5.88 trillion miles. This unit of measurement is used to express the vast distances between stars and galaxies. For example, the nearest star to the Sun, Proxima Centauri, is about 4.24 light-years away. The use of light years helps astronomers convey the immense scale of the universe and the vast separations between celestial objects. The Big Bang started it all. This theory describes the origin of the universe as a massive explosion that occurred about 13.8 billion years ago. The Big Bang marked the beginning of space and time, and it set the universe on a path of continuous expansion. The evidence for the Big Bang includes the cosmic microwave background radiation, which is the afterglow of the initial explosion, and the observed redshift of distant galaxies, which indicates that the universe is still expanding. And finally, Earth formed from cosmic dust and gas. Our planet began as a swirling cloud of gas and dust that gradually coalesced under the force of gravity. Over millions of years, this material clumped together to form planetesimals, which eventually merged to create the early Earth. The young planet was a molten mass, but it gradually cooled and solidified, forming a crust. Volcanic activity and the impact of comets and asteroids brought water and other essential elements to the surface, setting the stage for the development of life.